Hi everyone, we're going to go ahead and start with 1-3 solving equations. Your homework for tonight, just so that we can clarify on what it is on page 5 and 6 of your workbook. On page 5, the problems that you were assigned were number 15, 17, 18, 21, and 22. Okay. Then on page 6, you were assigned number 19. So let me write that down here. Page 5, and then page 6 was problem number 19. The 3 problems that I'm going to be working on is going to be 2 on page 5, are going to be 17 and 21. And then on the back side, I am going to be working on problem number 19. Okay, so let's go ahead and get started with problem number 17. All right, I'm first going to rewrite that problem so that I have more room to write. So I have 3t equals 2t plus 5. What we're trying to find here is what is the value of t? So thinking about the steps that we wrote down today, first off, I asked myself, is there any distribution? Then I need to know, can I combine terms on either the left or the right side? Well, on the left side, there's only 3t, so I can't combine that. On the right side, there's 2t plus 5, but since the 5 does not have a t, we cannot combine those either. So then I say I'm going to move all the variables to one side of the equation. So I'm going to look for the variable term that is smaller. So either 3t or 2t. 2t is smaller, so that's the one that I want to get rid of. So the inverse or the opposite of 2t is negative 2t. Okay, so 3t minus 2t gives me t, or 1t, but 1 times t is just t. 2t minus 2t, that cancels out, so then I'm left with t equals 5 as my solution. All right, now what I'm going to do though is I'm going to check my work. So when I'm checking this work here, I'm going to take that 5 and I'm going to substitute it back into the equation, the original equation, everywhere there was a t. So I'm going to replace all of those t's with an open set of parentheses so that, or an empty set of parentheses, so that I can substitute in 5. Okay, so I'm going to substitute in 5. All right, let's go ahead and see if the left side is the same value as the right side. 3 times 5 is 15. 2 times 5 is 10. 10 plus 5 is 15, and that is correct. All right, so let's go on to number 21. This one is a minus 2a over 5 is equal to 3. Now, I've heard you all say how much you dislike that 5 in the denominator, and we've talked about how to eliminate the fraction so that we may have larger values, but we will not have that denominator. So how do we get rid of dividing by 5? Well, the inverse is multiplying by 5. So what we have to do is we have to multiply every term by 5. Okay, and 5 over 1, that's the same thing as 5. All right, 5 divided by 1 is still 5. 5 times a, that gives us 5a. Okay. And the second one here, 5 divided by 5, well, that cancels out. So what we are left with is negative 2a equals 15. Now, on the left side, we can combine like terms. Okay, so we will combine those two. 3a equals 15. Divide both sides by 3 because that's the inverse of multiplication. And we get a is equal to 5. Now, to check our work, I'm going to rewrite out that equation. So I've got a minus, well, I don't want the a there because I said that I was going to actually put an empty set of parentheses for each a, minus 2 times a divided by 5 equals 3. Let's go ahead and just drop that line there so I can kind of see both sides of the equation. Substituting in 5, once again, it just happens to be 5. No rhyme or reason from problem 17, it's just what it is. So then here, I've got 5 minus 10 divided by 5 is equal to 3. So that gives me 5 minus 2. So that does come out correct, that 3 equals 3. Okay, so my solution of a equals 5 is correct. The second part is just checking our work. Okay. All right, one more problem to do together, and that is going to be number 19 on the next page. So turn over to the next page and let's go down to that one. Now I'm looking at number 17 that had decimals. I think there was one more above that had decimals that you were assigned. I can't remember off the top of my head because I've whited them out on here. Think about when you're doing decimals though, you're just lining up the values. So lining up the tenths, the hundredths, the ones, the tens, and just making sure your decimals are stacked up, okay? All right, so let's go down to number 19. All right, on number 19, we have 5 times 6 minus 4v is equal to v plus 21. Okay, let's do distribution first so we can get rid of those parentheses there. 5 times 6 is 30 minus 20v. Okay. Getting all the v's to the same side, I want to move the one that is a smaller in value. So negative 20 is actually smaller than positive 1. Okay. So let's go ahead and move over that negative 20. So I'm going to add 20v to both sides. Just forgot to put that in the other color to show that I'm doing inverse. All right, so then I've got 30, negative 20, and positive 20. They zero out, is equal to 21v plus 21. Okay. Now, let's go ahead and add or subtract 21 from both sides, doing that inverse operation. So I've got 9 is equal to 21v. Divide both sides by 21. This here reduces to 1. So I get V is equal to 9 over 21, which can be reduced to 3 over 7. Okay. Now we still have to check our answer. So keeping in mind that V equals 3 over 7 means that we are going to have a fraction that we are going to have to check with. Okay, this is like the second example that we did in class today. All right, so I'm going to go over here to the side and work on that. Let me get rid of some of this stuff that I have here. All right. So I'm going to take the original equation of 5 times 6 minus 4 V is equal to V plus 21. And everywhere there's a V, I'm going to substitute in 3/7. Now this is one where I'd love you to pause this right here. See if you can simplify inside that grouping or try to simplify those fractions and then come back and watch the rest of this. All right, so what I'm looking at first is the actual grouping. So the 5 on the outside is still there for right now. Okay, I'm going to leave this 6 because I'm just going to do one step at a time. What I want to see first, our shortcut is, can 4 be divided by 7? Which it cannot. So we've got to do this still just multiplying the numerator times the numerator and the denominator times the denominator. So we're going to have negative 4 times 3 is going to give us negative 12 over 7. And I'm going to work all on the left side and then I will go to the right side. Okay. So now I have 5. Well, they have to have a common denominator. So this one right now is currently over 1. Okay, but I need it to be over 7. Oops, what did I do there? 4 times 3 is 12 over 7. All right, so if I want this 6 to be over 1, I'm going to have to multiply it by 7, but whatever I do to the denominator, I have to do to the numerator. So I will have 5 times 6 times 7 is 42 over 7 minus 12 over 7. 42 minus 12, that gives me 30 over 7. Okay. Now, if 5 was divisible by 7, I could use that method, but since it's not, I've got to just write it out. 5 times 30 is 150 over 7. Okay, so our left side is equal to 150 over 7. So I've got to do the right side and hope that it also comes out to 150 over 7. Okay, so let's keep working on that one. This one's not so bad because that first one's already a fraction, so it's 3 over 7. It's 21 over 1. That has to have a common denominator. So I've got to multiply both the top and the bottom by 7. 21 times 7. Well, 20 times 7 is 140. 1 times 7 is 7. So that gives me positive 147 over 7. Now that I've made them have a common denominator, we can add them, and that comes up to 150 over 7. These two match. That there probably deserves like a double or a triple gold star to know that we did that problem correctly. Okay, so our solution really is V equals 3 over 7.